Hello everyone, my name is Joe Scorson, channel is called Ethernet Wink, and in today's video we're going to be continuing with the Quant Finance Advent to Code series. So in today's episode, what we're going to be doing is we're going to be calculating option prices with the Black Scholes model. We're going to again build on the code that we wrote in the last few episodes to get the necessary parameters and data that we need to do this. So in the next few videos, we're going to be doing option pricing models, and then we're going to get into the more kind of back-end infrastructural stuff like an order book with a bunch of different order book types, parallel backtester in Python. I'm going to do it in Python. Then we're going to actually simulate portfolio returns with multiple different strategies trading at once in the same strategy, like at metrics, and we're going to stress test it. And then we're going to build just way cooler stuff, some machine learning stuff. I hope that you guys stick around for all of it. Now, before we get into the actual code, thank you guys for over 100 followers on this account. I wanted to hit 100 by the end of the year. It's the beginning of December, and I'm already at 125, so that's just amazing. Thank you guys for that. And if you guys trade actively yourselves, check out the indicator I made with LuxAlgo. You can see me post a bunch of stuff with this on my Twitter account. I trade with it on Spaces. Hop in, listen to us talk on Spaces. It's a bunch of other really good traders. Even if you don't want to listen to me, there's somebody there I think that you'll like to listen to. So, hopping right into the code then. Let's check out our task. So let me move my face so we can all read this. So get stock data, then using the Black Scholes model, calculate the rolling price of at the money 30-day till expiration call and put options. Use 0.03 for the risk-free rate and the annualized volatility we calculated in the last task for the volatility. Use subplots to plot the price and the premiums. Sweet. Okay. Sounds like a fun one. So this is the get stock data function that we did in the last episode. And here is the the calculate volatility function that we did, the one before this function, before this video. And so right here in our main, I'm just doing it on Apple. We have pretty much a year of prices. Get our stock data and then calculate the volatility on it. Now let's write out this Black Scholes model function. So for the Black Scholes model, we need the D1 and D2 values. So D1 represents np.log, our spot price over our strike price. Then what we need to do is we need to add the risk-free rate plus 0.5 times sigma squared, not add sigma squared. There we go. And then we need to multiply that by the time to expiration. And then we need to put all of that over sigma times the square root of t. And remember, we're going to do it later on when we actually give it the inputs for this. But t is in years. So even though t is like the days till expiration, let's say it's 30. So it would be 30 over 365 would be how you do that. That being said, we now have our D1. So now let's use that to get our D2 variable. So D2 will be D1 minus sigma times the square root of 2. Cool. Now, depending on if the option type is a call or put, we need to do things differently. So if option type is call, we need to return the spot price times the norm.cumulative density function. That will be an import that we need from scipy.stats import norm, along with the regular stuff the stuff we already had and the stuff to plot. So norm.cfd. Then we're going to put our first derivative in there. Then we're going to subtract it by our strike price times e to the negative risk-free rate times t. And then multiply that by the norm.cfd of d2. That, I'm just making sure I typed that out right. I'm pretty sure I did. It looks right. It is right. That will give us the price for a call option. So then if it is a put, we need differently. and I'm just going to do this now. Else I'll return like invalid contract type. Cool. So now if we do get the right thing, we need to return our strike price, not the spot price, but the strike price times mp.exponential. Again, negative risk-free rate times time to expiration, and then multiply that by the norm.cfd of negative D2, so that way they appreciate when the stock goes down, minus S, and then times the norm.cfd of negative D1. And that will give you the premium for a put option. So now that we have like kind of this helper function, what we need to do is we're going to use this in a different function. So we're going to say def calculate option price, and then BS for Black Scholes, and data, and the only thing that we're going to set constant is the risk-free rate. I'm going to set that to be 0.03 like the task said, and then pass. Risk-free rate means it means like what is the expected return to get for zero risk. Normally it's like a 10-year bond yield or something like that. People use different things for, like if you want to be aggressive, it would be like the average return of the S&P 500, and then a more considerate thing would be like a tips return, you know, like something like that would be really small. So now to start this off, we also need to set our days to expiration in this. And I'm going to set that default to be 30, like the task asked for. Excuse me. Then we're going to say days to expiration over, and actually 252, not 365, because there's 252 trading days in a year. And then we're going to say our data is data dot make sure we have no NAs, and we want to copy it. So that way we're not just like referencing it, we're actually getting the different data in this, because we're going to add stuff to it. So we can say data dot lock, and then we want everything, and we want to apply this to a column called call price. Is data dot apply. Apply is a very useful function, and then we're going to use lambda. So lambda row is we're going to do this Black Scholes function on it. So we're going to say S is the rows. It's a capital C, yes. Row.close. K is going to be the same thing, because actually in my, I believe in the code I posted on GitHub, I did it +1. So I'll just keep it consistent, and then I'll show you why that's like not the best thing to do, but for now it's fine. Risk-free rate, set our sigma to be the row's annualized vol. I just want to make sure I spell that right. The annualized vol. And then what else do we need? We need the option type to be a call. And then this is for the call price column. For the put prices, what I'm going to do is I'm just going to copy this, chuck it down there, say put price, put, make sure I didn't capitalize that in there yet, lowercase, and then subtract 1 from that, and that would be all. Oh, there's one more thing we need to add to this apply. We need to specify that the axis is 1. So now let's add that to both areas. There we go. Now, let's just make sure that data gets calculates option price BS data, and then we're going to print data dot head just before we plot it. Just make sure that we have no errors and everything is going right. None type object has no attribute head. It might help if we return it. That's always nice when you return what you just worked on. There we go. So now we have a call price and a put price. Gorgeous. Writing a function and actually returning the thing that you want to return, it just tends to help in programming. So now with that all done, let's plot with options, data, and a ticker is all we're going to need for this function, like our data frame. And so now we're going to say fig gets make subplots. I want 3 rows. I want 1 column. And I want the shared x-axes to be true. Then I want my vertical spacing to be 0.02. I want the row heights, like how you understand me, of everything, to be we're going to specify, we're going to give it a list. We want the actual price of it to be the bulk of it, and then we can specify that the 2 option prices are going to be smaller. So that all adds up to 1, right? And then the subplot titles, we're going to again give it, we're actually going to give it a tuple, is what it wants. We're going to say candlestick chart, call premium, and then put premium. We're going to capitalize this C so I don't lose my mind. There we go. Cool. So now we're going to say fig.add trace. So go.candlestick. So our X is going to be data.index because it's already in date format. Open is going to be data open high. I can never do this fast. I've done this a million times, but I've never been able to do it quickly. Low is data low, and these are all need to be capital first letters as well. Don't forget that. And then close, class name. Close is going to be data close. There it is. Give it a name, not that. Give it a name which is going to be price. And then down here we're going to say row 1, column 1. Cool. And I want to say capital C candlestick, so that way we actually access the right thing. Next, I want to add the subplots. So I'm going to say fig.add trace, and I'm just going to do this as a line chart. So we're going to say go.scatter with a capital S, x equals data.index, and then our y is going to be our data call price. Is that what I call the column? Yep, sure did. So then with that, we can say mode is going to be lines, name is going to be call price, and then for the color, we're going to say we have to set it to a dictionary where color gets green, and then just outside of all those parentheses, we want to specify that this is for row 2, still in column 1. And then let's just copy this. That way we can just change this to put price and change the color to red and say row 3. And then we're going to say, I'm just going to copy and paste this because there's a lot of typing and I'll go over it. I know it would just take me forever. So we would say fig.update layout. Give it a title for stock analysis. I don't like the range slider, so we're going to get rid of that on the x-axis. X-axis 3 title is date. Then we have price, or then on the y-axis title for the first plot. The first plot that we have right here in row 1, column 1, right? That's the first one. We have price, and then row 2 is call price. Row 3, put price, and set the overall height to be 900 and show legend to be true. And then we're just going to call fig.show. We're not going to return it, but we're just going to call it in the function. And so then we are just going to say, and I actually remember this function does have other parameters, but we just set it to be the defaults already, so we don't have to worry about that. I'm going to say plot with options, data, ticker. And then when you call this, if you get no errors, nothing should happen on this screen, but perfect, what just happened to me should happen to you. It'll bring it up on a screen, brought up on the other screen just because it was the last one I clicked. And so here we go. We have Apple's prices, and then we have our option premium. You might be wondering, why are things appreciating at the same rate? Well, they're not. So what happens here is that volatility picks up, right? There is a bit of an increase in volatility. And also we're calculating the rolling price of contracts. So the simple fact that on June 11th right here, the close is at 207 and the day before it was at 193. I don't know what happened this day for it to go up $14 like that. But when you price the option out, what'll happen is the fact that our spot price and strike price increase at the same time, and our volatility goes up, that will just make it's a rolling, it'll always be the at the money contract. So because the overall price is increasing, you're just gonna have a bigger number. And then because volatility is increasing, the contract will literally be more expensive. I hope that makes sense. The fact that like if we were to change this to a stock like F that is just very inexpensive in comparison to Apple, what would happen, I'm gonna pull this up so we can have it next to it. And then, yep. So what would happen is that you can see here the change is still stark from 5 cents to 33 cents, right? But it's just because the numbers are changing so drastically. And here is actually a better example because the calls are still going up even though the price is smaller, because this is showing how the volatility will change it so dramatically. This is the perfect, best example I could have thought of, because right here you can see more volatility, bigger numbers. But here you can see the call premium is still increasing because we're still pricing the at the money. We're still pricing the same kind of contract that we'd be pricing anywhere else, but that time it has more volatility than all the others. Because look at it, right? You can clearly tell that this is a volatile event. Does that mean you would have made money if you held these options? No. But that means that the volatility would have kind of just jacked everything up. And so now this is a good time, I think, to talk a bit about option pricing and volatility. I wanted to see my face there too. But I'm going to bring up Microsoft Paint for a second, and we're just going to talk about volatility and market pricings, right? Because you might be seeing that and thinking to yourself, like, okay, like that's literally what happens when I open up my brokerage. Is like the Black Scholes Model has been going on forever and ever and ever, and what I'm seeing right there is the prices. That is misleading. That's not always the case. Why is that not always the case? It's not always the case because, okay, I can't F11 with Paint, I guess, whatever. That's not always the case because let's say our Black Scholes priced option is $1 and it's a call, right? And let's say it's on NVIDIA. And everybody has been bullish on NVIDIA, right? Everybody's been bullish on NVIDIA. Everybody thinks it's going to go up. So a call that's priced at $100 might be trading at $1.20, even though no changes happen. Even though it's the same old NVIDIA. Why would that happen? Maybe there's news in the future. Maybe they got earnings. Maybe the sentiment is just so bullish. Maybe it had a volatile move and it's priced above what it actually should be priced. Because it's a hard concept to understand, I think, without an example, like just doing it like this. But if anybody has ever been IV crushed from earnings, like you know what I'm talking about, like you'll be holding the same, you could be right on the direction and lose money with options. That's why you have to be so careful when you purchase them, right? You really have to understand how jacked is the IV on this option. How cheap is it relative to other volatilities? Is it a volatile time right now, and is the contract cheap? If that's the case, I want them, right? I don't really care what the actual trade is, but I want some of those contracts. And it goes both ways too, right? Let's say call should be priced at $1, right? We're just going to use the same example. And then we get, I don't know, a downgrade in the morning. So we get a little downgrade on whatever stock we're looking at. And so those calls that should open up at $1 at the decreased price, right? So open, mod on, drawing with a mouse, at $1. Open at $1 with the down, right? Well, because it was a downgrade and we got news right there, they might actually open at 90 cents, right? Because nobody wants them anymore, right? They all want to get rid of them, so they're just gonna sell it to whoever's buying, right? That is just as much as an opportunity. Like, yeah, there's a downgrade, but I have 10 cents just as a cushion. I have 10 cents that like I should have. So if I were to buy this option at $1, and let's say I'm still wrong though, it goes down to 80 cents. Well, I lose 10 cents instead of 20. Or if I'm right about the direction and it goes up to $1.40, not only do I just have a bigger payoff, but I got to risk so much less on the buy. That's the point I want to make to you guys, is how risking works on buys or not. I have a great video on my channel where I explain code. I don't code it along with you guys, so it's not the bulk of the video, where I do this in C++ with the Monte Carlo simulation, talking about implied volatility and stuff like that. I encourage you guys to go watch that because it's a bit less about code implementation and about the abstract of the market. So yeah, if you guys made it to the end of this video, listen to me blab along, I really appreciate that. I hope that you guys enjoyed day 4's challenge. I hope that you guys take a look at my indicator with Lux Algo and at my Twitter account. I'd really appreciate it. But yeah, catch you guys in the next one. I hope you guys enjoyed this challenge.